There is a place where the sun is nothing more than a star. It is not a burning disk that warms the skin. It is just a piercingly bright dot in a canvas of absolute, suffocating black. In this place, there is no wind, there is no sound, there is no day, and there is no night. There is only the vacuum stretching out for billions of miles in every direction. It is the loneliest place imaginable, but in this deep, obsidian silence, something is moving. If you could drift out there, to the very edge of interstellar space, you would see a glint of metal against the darkness. It is a machine, a spider-like construct of aluminum dishes, gold foil, and spindly sensors. It is traveling at 38,000 miles per hour, tearing away from the solar system that gave it birth. This is Voyager 1. It is the furthest human-made object in history. It is a piece of Earth that will never, ever return home. But Voyager is not just a scientific tool, it is a vessel. Bolted to its side, protected by a gold-plated cover, is a phonograph record, a literal golden disc. And on that disc, we carved our soul. We carved the sound of rain. We carved the music of Mozart. We carved the sound of a mother kissing her child. We carved the electrical signature of a woman falling in love. We threw this bottle into the cosmic ocean, hoping that maybe, a billion years from now, someone or something would find it. But before Voyager left us forever, it did something heartbreaking. It looked back at the darkness it came from, and it took one last picture. A picture that contains everything you have ever loved and everything you have ever known, reduced to a single pixel of pale blue light. Tonight we are going to follow this traveler. We are going to go back to 1977 to the moment the engines ignited. We are going to ride the gravity of giants. We are going to witness the storms of Jupiter and the rings of Saturn. And we are going to journey to the edge of existence to understand why a machine made of metal has become the most human thing we have ever built. To understand the miracle of Voyager, we must first understand the silence from which it was born. Before 1977, the outer solar system was a place of mystery. We had seen Jupiter and Saturn through telescopes, yes. We knew they were giants. We knew they had rings and moons, but they were fuzzy, indistinct shapes. They were abstract concepts, not worlds. We did not know about the volcanoes of Io. We did not know about the oceans of Europa. We did not know about the methane rain of Titan. The outer dark was a locked room, and we had lost the key, but the universe runs on clockwork. It is a mechanism of immense, slow-moving gears. And in the 1960s, a young doctoral student named Gary Flandreau, sitting in a quiet office at the Jet Propulsion Laboratory in California, noticed something in the math. He was plotting the future positions of the planets, drawing lines on a chart, when he saw a pattern that made his heart skip a beat. He realized that in the late 1970s, the four giant planets, Jupiter, Saturn, Uranus, and Neptune, would arrange themselves in a graceful, perfect curve. It was a celestial alignment that happens only once every 176 years. This alignment was a gift. It meant that a spacecraft could use the gravity of Jupiter to fling itself toward Saturn, then use Saturn to fling itself toward Uranus, and so on. It was a cosmic game of billiards, a grand tour. Without this alignment, a trip to Neptune would take 30 years of fuel and patience. With it, the trip could be done in 12, but the window was closing. The alignment was rare, and it was fleeting. If humanity wanted to see the outer worlds, we had to launch in 1977. If we missed that date, we would have to wait until the year 2153. We had one chance. So NASA went to work. They didn't just build a machine, they built an ambassador. The Voyager probes, Voyager 1 and Voyager 2, were designed to be survivors. They had to be. They were venturing into environments that would kill a human in a fraction of a second. They had to survive the intense radiation belts of Jupiter, which can fry electronics like an egg in a skillet. They had to survive the freezing cold of deep space, where the temperature hovers near absolute zero. They were built with redundancy. 2 computers, 2 radios, backup thrusters. If one part failed, another would wake up to take its place. They were autonomous, programmed to think for themselves, because out there, radio signals take hours to travel back to Earth. If Voyager faced a crisis, it couldn't wait for instructions. It had to survive on its own. But while the engineers were soldering circuits and calculating trajectories, another group was working on the soul of the mission. Carl Sagan, the famous astronomer and science communicator, understood that Voyager was unique. He knew that once these ships passed the planets, they wouldn't stop. They had enough speed to escape the sun's gravity. They would drift between the stars forever. He realized that Voyager was likely to outlast the Earth itself. Long after our sun swells into a red giant and swallows our planet, Voyager will still be drifting, intact, in the silence of the Milky Way. He proposed a romantic, audacious idea. We should put a message on board, a greeting card, a time capsule, just in case. NASA agreed, but the timeline was tight. Sagan and his small team had only a few months to curate the entire history of the human species. How do you explain Earth to an alien civilization using only sound and images? What do you include? What do you leave out? They sat around a kitchen table arguing and dreaming. They decided to create a phonograph record, a 12-inch disc made of copper, coated in gold. It would be durable. It would last for 1 billion years. They encoded 115 images. Pictures of DNA, pictures of a fetus, pictures of people eating, drinking, running, and pictures of the Great Wall of China and the Golden Gate Bridge. They carefully avoided images of war, poverty, or disease. They wanted to put our best foot forward. They wanted to show the universe that we were a species capable of beauty. Then, they chose the sounds. Imagine sitting in a studio trying to capture the sonic fingerprint of a planet. They recorded the sounds of geology, volcanoes, earthquakes, thunder, wind, rain, and surf. They recorded the sounds of biology, the heartbeat of a human, the footsteps of a person walking on gravel, the song of a whale, the bark of a dog, the laughter of a child. They recorded greetings in 55 languages. It begins with the ancient language of Akkadian, spoken in Sumeria 6,000 years ago. A voice from the dust says, "May all be very well." It ends with a modern dialect of Chinese Wu. A voice says, "Best wishes to you all." And in between there is a greeting in English. It is not spoken by a president or a king. It is spoken by Carl Sagan's 6-year-old son, Nick. He says with the sweet, unhurried confidence of a child, "Hello from the children of planet Earth. Whatever happens to us, whether we destroy ourselves or travel to the stars, that child's voice is immortal. It is etched in gold, flying through the dark, waiting for ears that may not even exist yet. But the most profound data on the record is invisible. It is a secret. During the creation of the record, Carl Sagan and the creative director Anne Druyan fell in love. It was a whirlwind romance, born of the intensity of the project. A few days before the record was finalized, Anne Druyan went to a laboratory at a hospital in New York. She had her brain waves and heart rate recorded while she meditated. She closed her eyes. She thought about the history of ideas. She thought about the violence of the world. And then she allowed herself to think about the man she loved. She focused on the feeling of love, the rush of blood, the quickening breath, the profound sense of connection. This data, the sound of a human nervous system in love, was compressed into audio and etched onto the golden record. So, Voyager is not just a scientific probe, it is a mechanical heart. It carries the literal electrical signature of human love. It is a testament to the fact that we, small and fragile creatures on a rock, were capable of feeling something as vast as the universe itself. Cape Canaveral, Florida. The summer air was thick and heavy, smelling of salt and swamp grass. The cicadas buzzed in the marshes surrounding Launch Complex 41. On the pad stood the Titan Centaur rocket. It was a beast of a machine. It wasn't elegant like the rockets of the future. It was a towering stack of fuel and explosives, painted white and silver. Perched on top, folded up inside a protective metal shell, was Voyager 2. In a quirk of orbital mechanics, Voyager 2 launched first, on August 20th. It was on a slower trajectory, designed to visit all 4 outer planets. Voyager 1 would launch later but fly faster, overtaking its twin to reach Jupiter and Saturn first. The engines ignited. A shockwave of sound rolled across the Florida coast. The rocket lifted off, riding a pillar of fire into the blue sky. It arced over the Atlantic Ocean and vanished. 2 weeks later, it was Voyager 1's turn. September 5th, 1977. The countdown ticked to 0, liftoff. The ground shook. The Titan rocket screamed its way up. Inside the nose cone, Voyager 1 rattled and vibrated. The G-forces pressed against its delicate instruments. The heat of friction warmed the fairing. And then, silence. The engines cut off. The empty fuel stages fell away, tumbling back to burn up in the atmosphere. The protective shells split open and drifted into the void. Voyager 1 was free. It was floating in the black. It fired its small thrusters to stop its tumble. Its sensors scanned the darkness, looking for the brightest object in the sky, the sun. It locked onto it. It unfolded its main antenna, a large white dish, pointing it back toward Earth. It unfolded the long booms holding the cameras and the magnetometers. It looked like a metallic insect unfolding its wings after a long sleep. It checked its systems. Computer, online. Radio, online. Nuclear generator, warm. It was alive, and it was moving fast. Faster than a bullet. Faster than sound. It was falling away from the Earth, falling toward the outer dark. The first few weeks were a time of calibration. Voyager looked back on September 18, 1977, when it was 7.25 million miles away. Voyager turned its camera around and took a picture. It captured the Earth and the Moon in a single frame. It was the first time in history that we had seen our home and our satellite together as complete worlds. They looked like a double planet. The Earth was a bright, swirling marble of blue and white. The Moon was a dark, grey pebble hanging beside it. They were suspended in nothingness. It was a beautiful image, but Voyager could not linger. It had a schedule to keep. It turned its eyes forward. It crossed the orbit of Mars. It crossed the asteroid belt. In movies, the asteroid belt is a crowded, dangerous field of tumbling rocks. In reality, space is so vast that the asteroids are millions of miles apart. Voyager drifted through the belt for months and never saw a single rock. Infinite, empty silence. As it traveled, the sun began. On Earth, the sun is a blazing presence that dominates the sky. But as Voyager ventured deeper, the sun became smaller. It became a coin, then a button, then just an incredibly bright star. Without the heat of the sun, the temperature of the spacecraft began to drop. Voyager is wrapped in black thermal blankets to keep its heat inside, but its true warmth comes from its heart. Voyager does not use solar panels. They would be useless in the gloom of the outer solar system. Instead, it carries 3 RTGs, radioisotope thermoelectric generators. These are black cylinders filled with spheres of plutonium-238. The plutonium is radioactive. As it decays, it releases heat. The thermocouples turn that heat into electricity. It is a nuclear fire that burns slowly, day and night, year after year. This heat keeps the oil in the gears from freezing. It keeps the radio transmitter warm. It keeps the computer chips functioning. Voyager is powered by the slow death of atoms. It is a machine that eats radiation to survive the cold. January 1979. Voyager 1 had been flying for nearly a year and a half. It had traveled 500 million miles. And now it was approaching the king, Jupiter. For months, the planet had been growing in the camera lens. At first, it was just a bright star, then a disk, then a world. Jupiter is a monster. It is a ball of gas so massive that you could fit 1,300 Earths inside it. It doesn't have a solid surface to stand on. It is just an endless, crushing ocean of hydrogen and helium clouds. As Voyager raced closer, the details of the atmosphere began to emerge. It was a painting in motion. The cameras revealed bands of clouds, orange, white, brown, and red, swirling around the planet. They were moving at hundreds of miles per hour. There were storms the size of continents crashing into each other, merging and separating like oil on water. And there was the Eye, the great red spot. A hurricane that has been raging for at least 300 years. A storm so big that 3 Earths could fit inside it side by side. Voyager watched the storm spin. It saw smaller white storms get sucked into the vortex and devoured. It saw the turbulence in the wake of the spot, a chaotic mess of waves and eddies. But the planet itself was only half the story. The real surprise was the moon. Before Voyager, astronomers thought that moons were dead, boring worlds, balls of rock and ice, pockmarked with craters, frozen in time like our own moon. Voyager changed everything. It flew past Io, the innermost large moon of Jupiter. The scientists were expecting a grey, cratered rock. Instead, they saw a pizza. Io was yellow, orange, and red. It looked sickly, and it had no craters. Not one. While the navigation team was busy calculating the trajectory, an engineer named Linda Morabito was analyzing one of the navigation images. She saw a strange bulge on the side of the moon, a faint blue plume rising against the black of space. It was a volcano. Io was exploding. Voyager discovered that Io is the most volcanically active body in the solar system. It is caught in a gravitational tug-of-war between the massive Jupiter and the other moons. This tugging squeezes and stretches Io like a rubber ball, creating immense internal heat. The moon is constantly turning itself inside out. Volcanoes shoot sulfur plumes hundreds of miles into space. The surface is a hellscape of lava lakes and sulfur snow. Voyager flew through the edges of these plumes. Its sensors tasted the sulfur. It was the first time we realized that the outer solar system was alive with energy. Then Voyager looked at Europa. This moon was the opposite of Io. It was the smoothest object in the solar system. It was a ball of white ice, crisscrossed with long red cracks. It looked like a broken eggshell. There were no craters here either. This meant the surface was young. It was constantly being renewed. The data suggested something incredible. Beneath that shell of ice, there was likely a global ocean of liquid water. An ocean deeper than the Pacific, encompassing the entire moon. Kept warm by the gravity of Jupiter, this hidden ocean could contain more water than all the oceans of Earth combined. And where there is water and heat and organic chemicals, there could be life. Voyager didn't stop to drill. It couldn't. It was moving too fast. It took its photos, stored them on its 8-track tape recorder, and beamed them back to Earth. The signal took 40 minutes to reach the dishes of the Deep Space Network. On Earth, the printers were churning out the images. The scientists were ecstatic. They were popping champagne. They were seeing worlds that had never been seen before. But for Voyager, the encounter was brief. It used Jupiter's massive gravity like a slingshot. It dove into the planet's gravity well, stole some of its momentum, and accelerated. It picked up speed. It changed course. It was flung outward, faster than ever before. Behind it, the giant striped ball of Jupiter began to shrink. The chaotic dance of the moons faded into the distance. Ahead of it, a new star was getting brighter. Saturn, the jewel of the solar system. The encounter with Jupiter was just the warm-up act. The real beauty and the real mystery lay ahead. The rings were waiting. Voyager 1 sailed on into the darkness between the giants. The silence returned. The noise of Jupiter's radiation belts faded. The magnetic fields smoothed out. It was just the hum of the plutonium generator and the occasional click of the tape recorder. Back on Earth, the 1970s were ending. Presidents changed. Wars began and ended. Children grew up. But Voyager was immune. It was a silver dart etched with the dreams of its makers, flying through the cathedral of the cosmos. It carried the sound of a kiss. It carried the sound of the rain. And it carried a camera that would, one day, turn back to look at us for the very last time. But that moment was still years away. First, it had to survive the rift, and it had to meet Titan, the shrouded moon that would change its destiny forever. Space is not merely a distance, it is a waiting room. Between the kingdom of Jupiter and the kingdom of Saturn, there is a gulf of 400 million miles. It is an ocean of emptiness so vast that it defies human comprehension. For 20 months, Voyager 1 drifted through this void. The excitement of the Jupiter encounter had faded. The cameras were mostly quiet. The plasma wave instruments picked up only the low, static hiss of the solar wind. The spacecraft was in cruise mode. It was a silver needle threading the dark. Day after day, month after month, the sun grew slightly dimmer. The Earth grew slightly fainter. Voyager was alone. But it was not aimless. It was falling. It was falling along a precise mathematical curve, guided by the invisible hand of gravity toward a rendezvous that had been written in the stars for centuries. Ahead, a new point of light was separating itself from the background stars. It was a soft golden yellow. To the ancients, this wandering star was Saturn, the god of time, the god of agriculture, the slow-moving watcher in the night sky. To Voyager, it was the destination, and it was the most beautiful object in the solar system. August 1980. Voyager 1 began its approach. The cameras woke up. On the screens at the Jet Propulsion Laboratory, the image of Saturn began to grow. If Jupiter was a chaotic, violent painting of stormy reds and angry browns, Saturn was a dream of elegance. It was a ball of butterscotch and gold. It was banded, like Jupiter, but the colors were muted, softened by a thick haze of ammonia crystals high in the atmosphere. It looked pastel. It looked serene, but the planet itself was overshadowed by its crown, the rings. From Earth, through a telescope, the rings looked like a sheet of metal or ice surrounding the planet. As Voyager drew closer, the truth revealed itself. The rings were not solid. They were a blizzard. They were made of billions upon billions of individual particles. Some were as small as a grain of sugar. Some were the size of a snowball. Some were as big as a house. They were made of water ice, pure and shimmering. Imagine floating there. You are suspended in the vacuum surrounded by a river of ice. The particles are tumbling in slow motion, catching the sunlight, glittering like diamonds against the black velvet of space. They are constantly colliding, gently bumping into each other, breaking apart and reforming. It is a chaotic dance that creates a structure of perfect order. Voyager saw that the rings were not just one or two bands. There were thousands of them. It looked like the grooves on a phonograph record, a cosmic echo of the golden record carried by the spacecraft itself. The rings stretched out for hundreds of thousands of miles, yet they were incredibly thin. In some places, the ring system is only 30 feet thick. If you built a scale model of Saturn's rings out of a sheet of paper, the paper would be too thick to represent them accurately. They are a razor's edge of light slicing through the dark. November 12, 1980. The encounter. Voyager 1 accelerated. Saturn's gravity grabbed it, pulling it in at 45,000 miles per hour. It swooped over the cloud tops. The winds here were ferocious, 1,000 miles per hour near the equator, but from space, everything looked calm. The cameras snapped picture after picture. They saw strange things in the dark, ghostly smudges that rotated with the planet. The scientists called them spokes. They appeared and disappeared like phantoms. We still don't fully understand them. Perhaps they are clouds of electrically charged dust, levitated by Saturn's magnetic field. Voyager saw the shepherd moons, tiny moons like Prometheus and Pandora that orbit right next to the rings. Their gravity keeps the ice particles in line, like sheepdogs herding a flock. It saw Mimas, a small moon with a crater so massive it looked like a giant eye staring back at the spacecraft. It looked like a broken world, shattered by some ancient collision and barely held together by its own gravity. But for all the beauty of Saturn, Voyager 1 had a specific mission. A mission that would demand a terrible sacrifice. The mission planners had a choice to make, a fork in the road. They could send Voyager 1 on a path that would let it visit Saturn and then continue on to visit Pluto. Or they could send it to visit Titan, Saturn's largest moon. They could not do both. The orbital mechanics didn't allow it. To reach Titan, Voyager had to veer off course. It had to sacrifice Pluto. Why? Why give up a planet for a moon? Because Titan is special. Titan is the only moon in the solar system with a thick atmosphere. Astronomers knew that Titan was wrapped in an orange fog. They knew it had methane. They suspected that beneath that fog, Titan might be a frozen version of early Earth, a place where the chemistry of life was brewing in a deep freeze. It was a mystery box, and curiosity won. NASA decided to steer Voyager 1 toward Titan. They chose the mystery. This decision sealed Voyager 1's fate. By turning toward Titan, the spacecraft would be thrown upward, out of the plane of the solar system. It would never visit another planet. It would be sent into exile. The approach to Titan was tense. The moon appeared in the cameras as a featureless orange ball. It looked like a fuzzy tennis ball floating in space. The scientists hoped that as Voyager got closer, the cameras would penetrate the haze. They hoped to see oceans of methane, continents of ice, perhaps even rain. Voyager flew just 2,500 miles above Titan's cloud tops. It was intimately close. The cameras clicked furiously, but the haze did not clear. The smog was too thick. It was a wall of organic particles, impenetrable to visible light. Visually, the flyby was a disappointment. Voyager stared at the face of the moon, but the moon kept its mask on. But scientifically, it was a triumph. Voyager's radio signals sliced through the atmosphere. The sensors tasted the air. They found nitrogen. They found methane. They found ethane, acetylene, propane, complex hydrocarbons. They confirmed that the pressure on the surface was 1.5 times the pressure on Earth. It was the most Earth-like atmosphere in the solar system. And the temperature? minus 290 degrees Fahrenheit. It was a cold, dark, toxic wonderland. Voyager confirmed that methane could exist as a liquid on the surface. It suggested that somewhere down there, hidden in the orange gloom, there were rivers of natural gas flowing into lakes of lighter fluid. It rains gasoline on Titan. It is a world that is hauntingly familiar, yet utterly alien. As Voyager flew past, it felt the gravity of this strange moon. It felt the tug of the orange giant, and that tug changed everything. This was the moment of departure. Until now, Voyager 1 had been flying flat. Imagine the solar system as a dinner plate. The sun is in the center. The planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, orbit on the surface of the plate. They are all on the same level. This is called the ecliptic plane. Voyager had been sliding across this plate, moving from one marble to the next. But to see Titan, Voyager had to fly underneath Saturn. And as it swung past the moon, Saturn's gravity grabbed the spacecraft and flung it up, not north, not east. Up, Voyager was kicked out of the dinner plate. It was launched on a trajectory heading north, perpendicular to the orbits of the planets. Imagine a car driving on a flat highway, and suddenly it drives off a ramp and flies into the sky, never to touch the road again. That is what happened to Voyager 1 on November 12, 1980. It left the family of the sun. It left the plane where all the other worlds lived. It began its climb into the high wilderness of the galaxy. The encounter was over. Saturn, with its glorious rings and its shepherd moons, began to recede. Titan, the orange mystery, faded into a star. Voyager 1 was now traveling at 38,000 miles per hour, faster than ever before. It had stolen momentum from Saturn. It was moving so fast that the sun's gravity could never pull it back. It was now an interstellar object. The silence returned, but this time it was different. Before, between Jupiter and Saturn, there was a sense of anticipation. There was a destination ahead. Now there was nothing ahead, only the stars. Voyager 1 checked its systems. The scan platform, the motorized neck that held the cameras, was tired. The gears were wearing down. The computer was running smoothly, ticking through its routines in the hexadecimal language of 1970s code. The golden record was still there, bolted to the side, waiting. The spacecraft was healthy, but it was effectively retired. Its primary mission, exploring Jupiter and Saturn, was declared complete. NASA celebrated, champagne was popped. The headlines read, "Voyager triumphs." And then the team began to move on. Many of the engineers switched their focus to Voyager 2, which was still on the flat plane, heading toward Uranus and Neptune. Voyager 2 still had planets to see. It was the star of the show now. Voyager 1 was the forgotten sibling, the one who had left the party early to walk home alone in the dark. 1981 passed. 1982 passed. 1983 passed. Voyager 1 climbed higher and higher above the solar system. From its new vantage point looking down, the sun was no longer a neighbor. It was just a bright light in the center of the darkness. The planets were invisible specks, lost in the glare. The solar wind, the stream of charged particles flowing from the sun, began to thin out. Voyager was entering the heliopause, the borderland, the place where the influence of the sun begins to surrender to the influence of the galaxy. It was getting colder. The RTGs, the nuclear batteries, were slowly decaying. Year by year, the wattage dropped. The engineers back on Earth had to make choices. They couldn't run all the instruments anymore. There wasn't enough power. They turned off the heater for the camera. They turned off the infrared spectrum. They turned off the radio astronomy receiver. One by one, the sensors of Voyager were going dark. It was going blind. It was going numb. It was conserving its energy for the long, long drift. But Carl Sagan had not forgotten about Voyager 1. For years, he had been pestering NASA with an idea, a request. He wanted Voyager to do something dangerous, something unnecessary, something beautiful. He wanted to turn the ship around. Normally, a spacecraft always points its antenna at Earth. If you turn the ship to take a picture, the antenna points away and you lose contact. It's a risky maneuver. And pointing the delicate camera lenses back toward the sun could fry them. The sun, even from this distance, is very bright. The engineers said no. There is no science value, they argued. We have seen Earth. We know what Earth looks like. Why risk the spacecraft for a sentimental photo? Sagan argued back. It is true, he said. There is no scientific value, but there is immense human value. He wanted Voyager to look at us. He wanted to see our home from the perspective of an alien. He wanted to see how small we really are. He called it the family portrait. He wanted Voyager to take a picture of all the planets, Jupiter, Saturn, Mars, Venus, Earth, scattered around the sun like dust motes. NASA resisted. The mission managers were protective of their machine. They wanted to keep it safe for the interstellar mission, to measure particles and magnetic fields. They didn't want to risk blinding the sensors for a postcard. So, Sagan waited. He waited while Voyager climbed. He waited while the distance grew. He needed Voyager to be far enough away that the Earth would be separated from the glare of the sun. He needed the geometry to be perfect. 5 years passed, then 10. Voyager was now billions of miles away. Finally, in 1989, a new administrator took over at NASA. He was a former astronaut, Richard Truly. Sagan went to him. He made his case one last time. Let us take the picture, he pleaded. Let us see ourselves. Administrator Truly looked at the proposal. He looked at the risks, and he said yes. Orders were sent to the Jet Propulsion Laboratory. Wake up the cameras. Prepare the sequence. Turn the ship. It was a complex ballet. Voyager 1 was now so far away that a radio signal took 5.5 hours to reach it. The engineers had to write a program that would tell Voyager to turn its back on the void, find the sun, and then precisely angle its camera to find a tiny invisible speck of blue light. It was like asking a sniper to hit a coin from 10 miles away while spinning. The date was set February 14th, 1990, Valentine's Day. A love letter to the Earth. Voyager 1 warmed up its camera Vidicon tubes. It shook off the cold of a decade. It spun its reaction wheels. The chassis rotated. The big white dish turned away from Earth for a moment. The camera looked back into the center of the solar system. It took 60 frames, a mosaic. It snapped a photo of Neptune. It snapped a photo of Uranus. It snapped a photo of Saturn. It snapped a photo of Jupiter. It snapped a photo of Venus. It couldn't see Mercury. It was too close to the sun. It couldn't see Mars. It was lost in scattered sunlight. And then it looked for Earth. Earth was microscopic. From 4 billion miles away, our planet occupies less than 0.12 pixels of the camera's sensor. It is smaller than a grain of dust. Voyager opened the shutter. The image was stored on the digital tape recorder. The spacecraft turned back around. It locked its antenna onto Earth. And then it began to transmit. The data moved at the speed of light. It traveled past the orbit of Pluto, past Neptune, past the silence where Voyager had flown a decade earlier. It traveled for 5 hours and 30 minutes. It hit the giant dishes in Spain and California. The data trickled in. It was slow. The signal was incredibly weak. A whisper from the edge of the solar system. The engineers decoded the data. They assembled the mosaic. And there it was. Frame 3720. It was a grainy image. There were streaks of scattered light, reflections of sunlight bouncing off the camera's optics. They looked like beams of colored light, and there, suspended in one of those sunbeams, was a dot, a tiny, whitish blue speck. It was almost invisible. You could miss it if you had a speck of dust on your computer, but it was there. It was us. Carl Sagan saw the image, and he wrote words that would become immortal. Words that transformed a grainy scientific photo into a spiritual text for the secular age. He called it the pale blue dot. But before we read those words, we must understand what that dot represents. In that one pixel, there is every human being who has ever lived. Every king and peasant, every couple in love, every mother and father, every hopeful child, every inventor and explorer, every teacher of morals and every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Voyager 1 had completed its photographic mission. 30 minutes after taking the picture, the camera was turned off forever. There was no need for it anymore. There is nothing to take a picture of in the interstellar void. It is just blackness. So, to save power, NASA put the eyes of Voyager to sleep. The spacecraft was now blind. It flew on, guided only by the feeling of the magnetic wind and the touch of cosmic rays. It was leaving the neighborhood. The family portrait was its goodbye kiss, a final glance over the shoulder before walking into the eternal forest of the night. The silence that followed was different from before. This was not the silence of waiting for a planet. This was the silence of deep time. Voyager was now truly alone. The sun was just a star. The Earth was invisible. The radio signal was getting weaker every day. Back on Earth, the world kept turning. The internet was invented. Phones became computers. Empires fell. But Voyager kept moving. 38,000 miles per hour, 900,000 miles per day. It was climbing the gravity hill of the sun, fighting its way out. It was heading for a boundary that no one had ever crossed, the heliopause, the edge of the bubble, the place where the wind from the sun stops and the wind from the stars begins. No one knew exactly where it was. Some scientists said it was at 100 astronomical units AU. Some said 120. Voyager was the scout. It was walking into the fog, holding out its hand, waiting to feel the change in the wind. It would take another 20 years to get there. 22 years of silence. 22 years of darkness. But Voyager did not complain. It did not falter. It held the golden record tight against its chest, and it kept flying. After the camera was turned off in 1990, after the pale blue dot image was beamed back to Earth, Voyager 1 went blind. The engineers at NASA sent the command to shut down the Vidicon tubes. They cut the power to the heaters that kept the optics warm. The glass lenses, which had witnessed the volcanoes of Io and the rings of Saturn slowly cool down to the temperature of deep space, -400 degrees Fahrenheit. Voyager would never see anything again. It did not see the stars. It did not see the Milky Way. It did not see the darkness into which it was falling. It became a ship of ghosts, guided only by touch and hearing. It navigated by feeling the magnetic field lines of the sun. It listened to the whistle of the solar wind, and it drifted. For 22 years, nothing happened. From 1990 to 2012, Voyager 1 lived in the interstellar mission phase. On Earth, time moved fast. We built the internet. We mapped the human genome. We fought wars. We saw the turn of the millennium. A whole generation was born that had never known a world without Voyager in the sky. But for Voyager, time was static. There were no planets to visit. There were no asteroids to dodge. There was only the emptiness. The spacecraft was traveling at 30 to 8,000 miles per hour, covering nearly 1 million miles every single day. But the solar system is so vast that even at this speed, progress felt motionless. It was like a sailor in the middle of the Pacific Ocean, where the water stretches to the horizon in every direction and the boat seems to be standing still. Voyager was sailing through the heliosphere. To understand where Voyager was, you have to understand what the sun is. The sun is not just a light bulb, it is a breathing beast. It constantly exhales a stream of superheated plasma, charged particles, protons, and electrons. We call this the solar wind. This wind blows outward in every direction. It creates a giant bubble around our solar system, a protective cocoon. Inside this bubble, we are safe. The solar wind pushes back against the deadly cosmic rays coming from the rest of the galaxy. It shields us. It creates a warm magnetic harbor for the planets. Voyager was walking to the edge of this harbor. It was looking. The scientists knew the exit was there. They called it the heliopause, the boundary where the pressure of the sun's wind is finally stopped by the pressure of the interstellar medium, the gas and dust between the stars. But no one knew where it was. Was it at 80 astronomical units? 100? 120? Voyager was the scout. It was walking into the fog, holding out its hand, waiting to feel the wind change direction. Year after year, the data came back the same. The solar wind was still blowing outward. The magnetic field was still aligned with the sun. The engineers began to worry. Voyager was aging. Its nuclear heart, the plutonium generators, was decaying. Every year, the spacecraft produced 4 watts less power. It was slowly starving. To keep it alive, the team had to make painful choices. They had to amputate parts of the ship to save the brain. In the late 90s, they turned off the ultraviolet spectrometer. In the 2000s, they turned off the planetary radio astronomy instrument. They turned off heaters. They turned off data recorders. They were stripping Voyager down to its bare essence. Just the antenna. They were racing against time. They needed Voyager to reach the edge before it ran out of power. Just a little further, they whispered. Just keep going. And then, in the summer of 2012, something changed. The data coming back from the cosmic ray subsystem began to fluctuate. For 35 years, Voyager had been bathed in solar particles. It was swimming in the river of the sun. Suddenly, the river began to dry up. The count of solar particles dropped. Then it spiked. Then it dropped again. It was turbulence. Imagine walking out of a house on a windy day. When you are inside, the air is still. When you open the door, you feel the gusts. You are in the doorway. Voyager was in the doorway. August 25th, 2012, a date that will be remembered as long as human history exists. On this day, the sensors tasted a new reality. The solar particles, the wind from home, dropped to near zero. At the same exact moment, the count of galactic cosmic rays, high-energy particles from exploding stars and black holes, skyrocketed. The magnetic field stopped pointing back toward the sun. It shifted. It aligned with the magnetic field of the galaxy. Ed Stone, the project scientist who had been with the mission since 1972, looked at the numbers. He looked at the charts. He paused. He wanted to be sure. He waited for more data, but the trend held. Voyager 1 had done it. It had crossed the heliopause. It had left the bubble. It was no longer in the solar system. It was in interstellar space. It was the first human-made object to leave the cradle. It was now an alien object, sailing the open ocean of the Milky Way. Humanity has become an interstellar species. But out there, 11 billion miles away, there was no fanfare. There was no finish line ribbon to break. There was only a change in the wind. The warm breeze of the sun was gone. Voyager was now flying into the cold, hard wind of the stars. The plasma density around the spacecraft jumped by a factor of 40. The space between the stars is not empty. It is filled with a thick, cold fog of ionized gas. Voyager was now wading through this fog. And then, Voyager, it didn't hear it with a microphone. Sound cannot travel in a vacuum, not in the way we hear it on Earth. But sound is just vibration. And in space, Voyager carries an instrument called the plasma wave subsystem, two long antennas stretching out 30 feet from the body of the spacecraft. They act like rabbit ears on an old TV. In 2013, a year after crossing the border, our sun threw a tantrum. It released a massive coronal mass ejection, a tsunami of solar plasma. This tsunami traveled outward. It took a year to reach Voyager. When it hit the interstellar medium around the spacecraft, it caused the plasma to ring like a bell. Voyager recorded the vibration. The data was sent back to Earth. The scientists converted the plasma waves into audio frequencies that human ears could hear. They played the recording. It is a haunting sound. It is not silence. It is a high-pitched, steady drone, a shriek that rises and falls. It sounds like the wind howling through a haunted house. It sounds like the scream of a banshee. It is the sound of the interstellar void. For the first time in history, humans were listening to the song of the galaxy. It was terrifying, and it was beautiful. It proved that the space between the stars is not dead. It is alive with energy, with pressure, with violence. Voyager was sailing through a storm that never ends. Now that Voyager is out there, fully immersed in the alien dark, let us turn our attention to the cargo it carries. Let us look again at the golden record. Bolted to the side of the spacecraft, facing outward, is the gold-plated copper disc. It is 12 inches wide. It is covered by an aluminum jacket. On the jacket, etched into the metal, are instructions, a user's manual for extraterrestrials. There is a diagram of a hydrogen atom defining the unit of time. There is a star map using pulsars to triangulate the location of our sun, and there is a drawing of how to place the needle on the record. Inside, the record waits. It has a shelf life of 1 billion. Think about that time scale. 1 billion years ago, life on Earth was just slime in the ocean. 1 billion years from now, the Earth may be uninhabitable. The sun will be getting brighter. The oceans may be evaporating, but the record will still be there, pristine, shiny, new. It is the only thing we have ever made that is truly immortal. What is on it? We know about the greetings and the music, but let's look deeper. Let's look at the images encoded in the grooves. There are 115 pictures. They are not digital files. They are encoded as analog sound waves. To see them, you have to play the record and decode the buzz into lines of video. What did we choose to show the universe? We showed them a circle, a square, and a triangle to show that we understand geometry. We showed them definitions of mass to show that we understand physics. We showed them the structure of our DNA, the double helix, the code of life. We showed them anatomy, a diagram of a male and female, how we are born, how we grow, but then the images become personal. We showed them a picture of a hand to show dexterity and gentleness. We showed them a picture of a woman licking an ice cream cone. Why? To show how we eat? No. To show pleasure. To show that being alive feels good. We showed them a picture of a traffic jam in Thailand. To show that we are crowded, chaotic, and technological. We showed them a picture of the Sydney Opera House. To show that we build things just for the sake of beauty. We showed them a picture of a diver entering the water, a gymnast in midair. a sprinter crossing the finish line to show that we strive, that we push our bodies. There are no pictures of war, no pictures of poverty, no pictures of a mushroom cloud. Some critics said this was a lie, that we were whitewashing our history, that we were presenting a utopia that doesn't exist. But Carl Sagan argued that the message was not a history book. It was a wish. It was a representation of the best of us. It says, "This is what we wanted to be." There is a specific track of music on the record that captures the spirit of the mission perfectly. It is the song Cavatina from Beethoven's String Quartet No. 13. But the most poignant choice is a song by a man named Blind Willie Johnson. He was a blues musician from Texas. He was born in 1897. He was blinded as a child. He lived in poverty. He died of pneumonia in the ruins of his burned-down house, sleeping on a wet mattress because he wasn't allowed into a hospital. He had nothing, but he had a voice, and he had a guitar. He recorded a song called "Dark Was the Night, Cold Was the Ground." It has no lyrics. It is just him humming and moaning, sliding a knife along the strings of his guitar. It is a sound of pure, distilled loneliness. It is the sound of a human soul crying out in the dark, asking if anyone is listening. Carl Sagan included this song on the Golden Record. So now, the voice of a blind, poor man who died in misery is flying through the stars encased in gold, representing humanity to the galaxy. It is a redemption. It says that suffering is part of us, but so is the beauty that comes from it. Blind Willie Johnson is now the furthest human voice from Earth. He is singing to the void, and for the first time, the void is giving him the respect he never got in life. The record also contains the brainwaves of Andruyan. We talked about this before, the recording of a woman falling in love. But think about the physics of it. A thought is an electrical impulse, a firing of neurons, a tiny spark of energy. Usually, when you think a thought, it disappears. It dissipates as heat. But Andruyan's thoughts were captured. They were frozen in the geometry of the record's grooves. If an advanced civilization finds Voyager, and if they have sufficiently advanced technology, could they decode more than just the sound? Could they reconstruct the thought itself? Could they feel the sensation of that love, bridging the gap of millions of years and light years? It is a ghost in the machine, a consciousness preserved in amber. Voyager is not just a robot, it is a reliquary. It holds the sacred remains of our spirit. As Voyager traveled deeper into the interstellar medium, the silence became its only companion. The spacecraft began to slow down, not in speed, but in activity. The RTGs were dying. Every year, the voltage dropped. 1995, 2000, 2005, 2010. The engineers had to keep turning things off. It was a slow, agonizing process of saying goodbye to the instruments. Goodbye, plasma spectrometer. Click. Goodbye, ultraviolet sensors. Click. Goodbye, heater for the magnetometer. Click. Each click was a narrowing of the world. The spacecraft was pulling its limbs in to keep its heart warm. It was becoming like an old grandmother sitting in a chair by the window, wrapping a shawl tighter around her shoulders as the winter night sets in. She doesn't move much anymore. She doesn't see very well, but she is still listening. She is still remembering. Voyager is our grandmother in the sky. She is frail. She is tired, but she refuses to give up. There was a moment in 2017 that proved just how stubborn this machine is. Voyager needed to orient its antenna toward Earth. To do that, it used small thrusters, tiny rocket jets that puff out gas to turn the ship. But the primary thrusters were wearing out. They had been firing thousands of times since 1977. They were degrading. The engineers looked at the schematics. They saw a set of backup thrusters, trajectory correction maneuver thrusters. But there was a problem. These backup thrusters hadn't been used since the Saturn encounter. They'd been sitting cold and dormant for 37 years, in the vacuum of space, in the freezing dark. No mechanic in the world would bet on an engine starting after sitting in a garage for 40 years. But the team decided to try. They dug up old manuals from the 1970s. They learned the command codes that hadn't been spoken since the disco era. They sent the signal. Fire backup thrusters. It took 19 hours for the signal to reach Voyager and 19 hours for the reply to come back. The engineers waited. And then the data arrived. They fired. They worked perfectly. After 37 years of sleep, the engines woke up and did their job. The room at JPL erupted in cheers. It was a miracle of engineering. It was a testament to the people who built it. People who used slide rules and pencils. People who built things to last. It bought the mission another few years of life. But the end is inevitable. The plutonium is a finite resource. The half-life of plutonium-238 is 87 points. Physics is a strict accountant. You cannot cheat the decay rate. By 2025, Voyager will be critically low on power. NASA will have to turn off the last science instrument. By 2030, or maybe 2035, the transmitter will die. The radio will go silent. The carrier wave, which has been a constant presence in the Deep Space Network for 50 years, will vanish. The green spike on the screen will flatten into grass. We will stop hearing from her. We will send commands. Voyager, are you there? And there will be no answer. Just the hiss of the galaxy. But that is not the end of the story. That is just the end of the conversation. The end of the data is the beginning of the eternity. Voyager will become a silent ship, but it will not stop. Newton's first law of motion. An object in motion remains in motion unless acted upon by an external force. There is no air in space to slow it down. There is no friction. Voyager will keep coasting, 38,000 miles per hour, forever. It will leave the solar neighborhood. It will enter the Oort cloud, the shell of comets that surrounds our sun. It will take 300 years to reach it and 30,000 years to cross. Then it belongs to the Milky Way. It will orbit the center of the galaxy. It will complete one orbit every 225 million years. It will outlive the United States. It will outlive the English language. It will outlive the human species. It will outlive the sun. 5 billion years from now, when our sun swells into a red giant and consumes the Earth, turning our blue home into a cinder, Voyager will be far away, safe. It will still be shiny. The gold cover will still be bright. Blind Willie Johnson will still be humming his blues. The child will still be saying hello. The woman will still be falling in love. Voyager is our ark. It is the backup drive for human. As long as it exists, we are not truly gone. But where is it going? Does it have a destination? Is it heading toward a specific star? In the next and final part of our journey, we will follow Voyager into the deep future. We will track its path through the constellations. We will ask the question, what are the odds of it being found? And we will confront the ultimate philosophical meaning of this message in a bottle. We will look at what it means to be a species that shouts, "I am here," into an infinite canyon, knowing that the echo might never come back. There will come a day, it might be a Tuesday, or a quiet Sunday morning, around the year 2030, or perhaps 2035. On this day, a radio telescope operator at the Deep Space Network in Canberra, Australia, will sit at their console, drinking coffee, watching the screens. For 50 years, there has been a green line on that screen, a tiny, wavering spike in the radio spectrum. The heartbeat of Voyager 1. It has been the constant companion of space exploration, while empires rose and fell on Earth, while the internet was born, while children grew into grandparents. The signal was always there, but on this specific day, the plutonium generator on the spacecraft will finally drop below the critical voltage. The main computer will try to divert power. It will turn off the heaters. It will turn off the data tape. But it won't be enough. The voltage regulator will trip. The transmitter will starve. And on the screen in Australia, the green line will flicker, and then it will go flat. The operator will tap the glass. They will check the receiver gain. They will reboot the system. But the line will stay flat. The static of the universe will rush in to fill the silence. They will send a command. Voyager, acknowledge. 18 hours later, there will be no reply. They will try again the next day, and the next. But the conversation is over. The era of communication will end. Voyager 1 will still be there. It will still be intact. It will still be moving at 38,000 miles per hour. But it will be mute. It will be a silent silver coffin, tumbling slowly in the dark, carrying the memories of a dead world. This moment marks the beginning of the second mission, the mission of eternity. Until now, Voyager has been a reporter. Its job was to talk to us. Now, its job is simply to exist. Let us follow it into the deep future. Let us watch what happens when the human race is left far behind. The first landmark on this silent journey is the Oort cloud. This is the shell of the solar system. It is a vast, spherical cloud of icy comets that surrounds our sun like a thick fog. It is incredibly far away. Even moving at bullet speed, it will take Voyager 300 years just to reach the inner edge of the Oort cloud. 300 years. Think about the Earth 300 years ago. It was the early 1700s. No electricity, no cars, no United States. Think about the Earth 300 years from now. Will we be living on Mars? Will we be cyborgs? Will we be extinct? Voyager doesn't care. It will spend the next 3 centuries drifting in the vacuum before it even hits the boundary. And then it will take 30,000 years to cross the cloud. 30,000 years. That is a span of time longer than human civilization. While Voyager is dodging the silent, frozen comets of the Oort cloud, humanity on Earth might rise and fall 10 times over. Ice ages will come and go. The coastlines of the continents will change. The stars in the sky will shift their positions. And all that time, Voyager will be just a speck in the dark, slowly putting the sun behind it. Finally, it will emerge on the other side. It will be truly free. It will be an open interstellar space. The sun will be just another star, a moderately bright yellow dot, indistinguishable from thousands of others. Voyager will be guided by the gravity of the Milky Way itself. It will begin to orbit the center of the galaxy. It is no longer a solar system object. It is a galactic citizen. Does it have a destination? Is it aiming for anything? Space is mostly empty. The odds of hitting a star by accident are infinitesimally small. It is like 2 gnats flying in the Grand Canyon and hoping to collide. But Voyager does have a flyby on its itinerary. It is not heading for Proxima Centauri, our nearest neighbor. It is heading for a star with the unromantic name of Gliese 445. It is a red dwarf star in the constellation of Camelopardalis, the giraffe. It is a dim, cool star. It glows with a dull crimson light. Voyager is heading toward it, but it will not stop. In 40,000 years, Voyager 1 will make its closest approach to Gliese 445. It will pass within 1.6 light years of the star. To us, that sounds far, but in cosmic terms, it is. Imagine the spacecraft in that year. Year 42,025 AD. It will be colder than ever, near absolute zero. The gold cover of the record will still be shiny, polished by the microscopic dust of the interstellar medium. As it passes the red dwarf, the starlight will glint off the metal dish. For a brief moment, Voyager will be illuminated by a red sun. Will there be planets around Gliese 445? Maybe. Will there be eyes on those planets looking up? Maybe. If they have telescopes, they might see a strange, unnatural reflection moving through their system, a speck of light that moves differently than a comet. But Voyager will not wave. It will not transmit. It will slide past in the dark, a silent ghost from a forgotten world, and then it will fade back into the blackness. It will continue its orbit. Let us zoom out even further. Let us think in geological time. Millions of years. Voyager 1 will complete one full orbit around the Milky Way galaxy every 225 million years. Let's imagine its first galactic birthday, 225 million years from now. What will Earth look like? The continents we know, America, Africa, Asia, will have smashed back together or drifted apart. The human species will likely be gone or evolved into something unrecognizable. Maybe we will have left the Earth. Maybe we will be creatures of pure, or maybe we will be a layer of plastic and fossilized bones in the sediment. But Voyager will be completing its first lap. It will be exactly as it is today. There is no rust in space. There is no wind to erode the metal. There is no water to rot. The only damage will come from micrometeoroids, tiny grains of dust hitting the hull. Over millions of years, the surface will get pitted. It will look sandblasted, but the shape will remain. The golden record, protected by its aluminum cover, will remain pristine. The grooves will still hold the sound of the kiss, the sound of the rain, the sound of the blues. Now we must confront the ultimate fate of our home 5 billion years from now. Our sun is a middle-aged star, but like all, in 5 billion years, the sun will run out of hydrogen fuel. It will begin to burn helium. It will swell up. It will become a red giant. It will expand. It will grow large enough to swallow the orbit of Mercury, then Venus, and then Earth. The oceans will boil away, the atmosphere will be stripped, the mountains will melt, the rock itself will vaporize. Everything that we have ever known, every piece of art, every building, every grave, every memory will be consumed by fire. The Earth will be gone, but Voyager 1 will be far, far away. It will be safe. It will be floating in the cool darkness of the outer galaxy. And this is the profound realization. When the Earth is destroyed, Voyager 1 will become the only evidence that we ever existed. It will be the Ark. It will be the backup drive for the human species. Everything else will be ash. But the golden record will still be there. Blind Willie Johnson's voice will still be there. The diagram of our DNA will still be there. The child saying hello will still be there. As long as Voyager exists, humanity is not extinct. We are preserved in gold and copper, drifting among the stars. This brings us to the final question, the question that Carl Sagan asked himself when he designed the record. Will it ever be found? The universe is vast. The chances of an alien spaceship stumbling across a tiny silent probe are mathematically zero. It is like throwing a single grain of sand into the ocean and hoping a specific fish finds it. So, why did we do it? If no one is ever going to play the record, what was the point? Why did we put the music on there? Why did Andrew Yan record her? The answer is not about them, the aliens. The answer is about us. We built Voyager not because we expected an answer, but because we needed to speak. It is the same reason a castaway builds a signal fire, even if no ships are on the horizon. It is the same reason we carve our names into trees. It is the same reason we write poetry. It is a defiant act of. It is a way of shouting into the void, I was here. I felt things. I mattered. Voyager is a monument to the human spirit. It represents the part of us that wants to explore, the part of us that wants to connect, the part of us that loves beauty for its own sake. We are a species that evolved on a brutal, violent world. We are capable of terrible things. We fight wars. We destroy our environment. We hurt each other. But we are also the species that built Voyager. We are the species that gathered the sounds of our planet, not the sounds of bombs, but the sounds of rain and kisses, and sent them to the stars. When we look at Voyager, we see the best version of ourselves. We see a species that is curious, brave, and infinitely optimistic. Imagine a scene, a billion years from now. Somewhere in the Orion arm of the Milky Way, a starship travels through the dark. It is not human. Its crew is something we cannot imagine. Their sensors pick up an anomaly, a reflection. They slow down. They bring the object on board. It is pitted. It is ancient. It is primitive. They examine it. They see the diagrams. They figure out the code. They build a machine to play the disc. And suddenly, in the silence of their ship, a sound fills the air. Hiss. Hello from the children of planet Earth. Then, the sound of a humpback whale. Then, the driving rhythm of Chuck Berry's guitar. Then, the sound of a woman's brainwaves falling in love. They do not know who we were. They do not know that our planet is now. They do not know our names, but they feel it. They feel the vibration of life. They feel the joy and the sadness and the longing. And for a moment, two civilizations are connected across the abyss of time. We are not alone, and they are not alone. But even if that never happens, even if the record is never played, it is enough. It is enough that we sent it, because the journey itself is the answer. Voyager is out there right now. As you lie in your bed, safe under the blanket of the atmosphere, Voyager is rushing through the interstellar night. It is 15 billion miles away. It is cold. It is dark. But it is not lost. It knows exactly where it is going. It is going everywhere. It is the part of you that will live forever. So, tonight, look up at the stars. You cannot see Voyager. It is too small, too far away, but you know it is there. A tiny speck of gold, carrying a lullaby to the universe, drifting on the solar wind, sailing the cosmic sea, a silent ambassador from a pale blue dot, sleeping in the starlight, watching over the infinite. The signal has faded. The transmitter is cold, but the message remains. We were here.